Okay, so welcome back to Virtual Science 2021. It's the last lesson of this week. Yesterday, we learned a little bit about how we could separate the particles out of a solution. And just as a quick review, remember, particles in a solution are really, really small. They're completely dissolved. The light will pass right through a solution. So you can't really filter them or do anything else. So we talked about how you could let the stuff evaporate, and then the dissolved stuff would be left behind. And you would, if you used a distillation device, you could also recondense the liquid and get it back in its pure form. Now, as we said, in real life, people are separating stuff all the time. Okay, we make mixtures or we find mixtures in nature. We find iron ore or minerals that we want to use, but we don't find them out in nature all pure and ready for us to use. So we have to separate out whatever they were in, and we got to get them ready to be used. So, people are constantly separating mixtures and getting them into the usable parts. Now, one of my first jobs was at a place called Orange County Sanitation District in California. And what they did is it was a sanitation district, so it's just what it sounds like. They separated all of the waste material, the poop and the pee from the water, and we're talking a big city, so there are millions and millions and millions of gallons of water. And so what they had to do in their plant was get all the poop and the pee out of the water so that they could put the water back into a river and send it out to the ocean. So, the pee was more like a solution. So, they'd have to wait to evaporate it and do that. The poop is more like a suspension. So they wanted to get that stuff separated out, as quickly as possible because there was millions of more gallons coming every day. So, there's some real life, people actually do this stuff. It's not just learn about in school. So some of the terms that we're going to come up with in here is coagulation, and this uses chemicals to make particles in a suspension clump together, and filtration, like an air filter in your house or anywhere else, is a separation of particles in a suspension by passing it through a filter or paper or other substances. Now, if we have a suspension like that poopy water in Orange County, well, you just let it sit in a big pool, and eventually the stuff would settle and it would separate out. But it takes a long time. So a lot of times people want to speed that up. So we're going to talk about that. But naturally, particles will settle. So the particles in it says here in our reading, the particles in the suspension settle on standing. Large particles will settle out quickly, which makes sense. Smaller particles will take a longer time to settle. You can see how this works if you mix sand and clay with water and allow the mixture to stand or just sit. The sand will settle to the bottom in a few minutes, and the clay and the sand will take much longer. You would have to let the mixture stand overnight for the clay or the fine material to settle first. So here I have a bottle with a suspension in it. It's got sand and clay in the water, okay? And it's been sitting, so it's settled. Now, if I shake it up, okay, you look at it, it's all mixed together. But you can see right away that down at the bottom of the bottle, the sand has settled first. Now, if we let it sit overnight, okay, the clay, the brown stuff it's above the sand, is going to eventually settle out. So we may take a look at that next time we come together and see how it's actually settled out. You can see there the sand is at the bottom and the brown clay is still mixed. Now, if I wanted to speed this up right away, I could put it in a filter. Okay, so filtration is one way that a suspension can be separated quickly is filtration. Filtration is removal of particles by passing the suspension through a filter. Okay, so I could take, and I have this funnel, I put a filter, like a coffee filter in here, and I dump the suspension in there. Okay, the sand and the rocks are going to get stuck in the filter and the water will come out. Okay, and it says here that filters are made of paper or other substances. Filters have tiny holes or pores through which some of the substances can pass, but not other. Substances that cannot pass through the filter have particles larger than the holes. Now, I just have a regular coffee filter here, okay? And I have this flashlight, okay? And if I take and turn the flashlight on, put the filter over it and hold it up to the camera, you can see where the light is coming through the tiny holes in the filter. So even though the coffee filter looks like it's pretty solid, it's really not. There's little tiny holes where it allows the coffee that you're going to drink to come through the holes, and those little bright spots, those are the holes. And then it keeps the coffee grounds and stuff behind. So like if I poured the sand, the muddy water and the suspension through there, the water would come through, but the sand particles would be too big to fit. So when it says right here, filters have tiny holes or pores through which some of the substances can pass, and not others, that's what it means. Even the window, even the screen on your window is a filter. It allows the air to come through, but not the bugs. Okay? It's the same thing. Last year you learned about semi-permeable membranes. A semi-permeable membrane is the same thing. It's a filter. Some things get in, but not other things. Okay? Coagulation is another way to separate a suspension. And what people do is they add chemicals to it. So like at that sanitation plant, they put some chemicals in the water. It causes the particles to clump together. Well, then you have big particles that sink to the bottom faster, so you can speed this up, okay? So it says the chemicals make the particles of the suspension stick together. Particles form clumps that are larger and heavier than the original particles. As a result, the particles settle out more quickly. This process is called coagulation. Coagulation takes place when you cut your finger. You have chemicals in your blood that cause the blood cells to clump together into big clumps, and the big clumps are what stop the blood from pouring out the hole, so you don't bleed out. Now, in real life, some people don't have those chemicals. They're called hemophiliac. So if they get a cut, they need to really go to the doctor because they will continue to bleed because they don't coagulate. So that's a real life example of coagulation. And then the last way we can separate a suspension quickly is by a centrifuge. Okay? A centrifuge is when you spin the stuff around and some of it spreads, gets sprayed out and the other stuff sticks. So like this washing machine at your house on the spin cycle is a centrifuge. When it gets done washing, you have water and clothes in a mixture, and you want to get as much of the water separated from the clothes as quickly as possible so that when you put them in the dryer, they're not sopping wet. If you just put them in there where they were sopping wet, it'd take forever for the dryer to get them dry. So by separating the mixture, getting the clothes separated from the water, you can finish that process by evaporation, which is one of the things we learned about when we put them in the dryer. Okay, so the third way to separate a suspension is to spin the mixture at high speeds. The device is used is called a centrifuge. So like the washer spinning around. The suspension is spun around. The particles in the suspension are pulled to the bottom. The use of a centrifuge greatly increases the rate at which the suspension settles. They use suspensions in doctors' offices. When they take the blood from you, they put it in these little test tubes, and they put it in a machine that looks like this. And then the machine spins really fast. Okay, so the blood came out of you, and then when it spins really fast, just like your washing machine, Red blood cells, which are the heaviest, sink to the bottom. And then you have some white blood cells. And then you have the plasma, which is what your blood is dissolved in. It's mostly salt and water. Okay. So they can separate this, and then they can test your red blood count, your white blood count, and they can find out whether, whatever it is they're looking for. They can separate the blood this way by spinning it. So there's a lot of things that are spun like this to get them separated more quickly. Okay, and that wraps up separating a mixture by the 3 different ways. There's a reading in your study, slide in your study packet that corresponds to this reading. So you should open up the PDF and take a look at that to answer the questions. And we'll see you next week.